Okay, I'm going to run through example 3 now and show you how to do it. Some of you have made some very good starts. Firstly, I did have a sound problem with example 2, so if you're watching this video, just let me reiterate a couple of things from example 2, the main ideas that I talked about at the end, and that was that sometimes, even if a question looks really hard, you've just got to go and throw mud at it until it works out. And with a proof question, as long as you don't make any mathematical mistakes, typically it will work out at some point. So you just got to have a crack, which most of you have done with your time on this, so thank you for that. So let me show you drawing a diagram first of all. This would be my approach to drawing a diagram. I'm just going to zoom out for a little bit. The position vectors of point A and B are A and B. So they're position vectors. That means that they come from an origin, O. And I'm going to put A out to here because it's the one that gets extended. And I'm going to put B out to here. So I'll call that B and I'll call that A. And so this is A and this is B. Then it says relative to origin O, so that helps anyway. Line segment OA is produced to C so that OC equals MOA. So I'm going to put C here. So when it says produced, that means it's taken further. Now, because OC equals MOA, M is being, because C is being produced, M is being implied that M is greater than 1. That's something to put in the back of my mind in case I need it. C is joined to D, which is the midpoint of OB. So the midpoint is probably about here. So I'll call that point D. And C is joined to D there. That's the midpoint of OB. So this is a half B. I'm just going to put all the stuff on the diagram now so I remember this. That's a half B. D is a midpoint of OB. E is a point on CD such that CE equals NCD. So E is a point on CD such that CE. Now we're also told in part B, so I'm reading ahead here, that A, E and B are collinear. So I'm actually going to draw this line from A through to B, and I'm going to call this point E. And that produces that collinearity, and it also gives me that CE equals NCD. So now the other thing I know here is that if CE is equal to N of CD, then N is less than 1, M is greater than 1. There's two pieces of information. N and M are both scalars. So there's my diagram. Any questions about the diagram? You probably don't have something that looks exactly like that, but ultimately you'll have something similar. Realistically, with those diagrams, you cannot draw OA and OB perpendicular, but I would typically aim to have one of them as horizontal or one of them as vertical. It just takes the whole bunch of diagonal line factor out of it. Had I planned this ahead a little bit better, I might have even considered, oh no, it's probably better that I don't have CD as being vertical because we don't know if that's true. But my diagram's got some clarity, but having OB as a horizontal helps me produce that clarity. So I'd be aiming for that in a diagram you've got to draw. And as I said, I'd probably give you 2 marks for getting to that. Now, question A says, determine OE in terms of A, B, M, and N. So that's OE. So I'm just going to put a little thing here. OE is there. The first thing I'm going to do is think about how can I get to OE? So I can get to OE by going, this would be a pretty good way, doing OD and then DE. That would work for me. The other way I can see is if I go right up to OC and then down to CE. I know stuff about OC and CD and OB. I could do this and to there, but I'm concerned about that because I don't really know much about AB. In fact, I don't know AB and E are collinear until part B. So I'm going to avoid that AB line, and I'm going to go with the blue or the yellow. And I think I've done a solution to this, that I went with the, it looks like I went with the yellow. So I might just go with the yellow and see how we go, okay? So I'm going to start by stating that the things that I know, this is always helpful. So OA is equal to A, and OB is equal to B, and OD is equal to DB, is equal to half B. So there's a couple of things for me. I know that OC, I've already written this above, I know, but I'll write it again. OC equals M of OA, M times OA. And so that means that it equals M times vector A. That might be important as well. I also know that CE is equal to N of CD. And actually, I know more about CE than I do about DE. So I think I'm actually probably going to go the blue line because I know that extra stuff about it. But I don't know anything about CD except that I can make the statement that CD is equal to it's equal to a negative MA plus half B. So I'm at a point now where I can see my blue line is OC, which is that, plus CE, which is that. I know OC already in terms of M and A. I know CE in terms of N and CD. So if I can work out what CD is, then I've pretty much finished the question. Now I know CD is equal to get from C to D, I don't know this path, but I do know this path, back to the origin and then out to D. So I'm actually going to use that path to determine my CD. So this is all just about picking paths that you know, knowing what you know and then following those paths to determine the vector representation of additional paths, and the more you build, the easier it gets. So I'm going to say, therefore, OE is equal to OC plus CE, which is equal to MA, that's OC, plus CE, which is NCD. I've overworked this a little bit, but that's all right, which is MA plus NCD is negative MA plus half B. So I've basically taken, at the risk of over-highlighting this, my CD is from here, and my N is from the N times CD, and my MA is from my known MA for OC there. And I'm plotting this route along the blue. So along there to CD, and then down here to E to get my OE. OC was really easy and well known. CE's taken a bit of work, but I've worked it out now. And I'm just going to write that neater. So that gives me OE, because remember the question says determine OE in terms of M, A, N and B. Well, I've done that now, I just need to rearrange it a bit. So I get MA minus NMA plus a half NB, and then I'll just factorise this to get M minus NMA plus a half NB, which is what we've got there. So that's our OE. Any questions on that? So it's a bit of a hoo-ha. It's a hard question. It's a bit of a hoo-ha, but really just take a second and think about it. If you draw a decent diagram, it's just about following those paths and following the right paths. Now, when I did my solution to part B, which I'm going to do with you now, I picked the wrong path, and I got myself down into a bit of a hole where I couldn't determine one of the line segments without ultimately just backtracking over something I was already using, which ended up in cancelling a lot of stuff out, and I got to like a 1 = 1 scenario. So I had a bit of a circular argument, and I had to make a decision to then change my approach and do it a different way. And that's all right, that happens sometimes. So just be aware of that as well. So let's have a look at question B. And question B is, if A, E and B are collinear, find M in terms of N. So this has involved a little trick that I'm going to use. And it comes from the fact, and this was my mistake the first time, it comes from the fact that I've been given a piece of information. A, E and B are collinear. It's almost certain that I will need to use that piece of information. If you're given a piece of information, assume that you'll be using it. So the first thing I really should have done, and I did in the second approach, is to recognise that if A, E and B are collinear, then A, E is parallel to AB, and in fact AE is equal to K of AB. Now this was a little bit scary. It actually worked for me, but it was a little bit scary because I've now introduced K, and I don't really want K there. So be aware, no, that was a bit worrying, but I'm not too worried at this point. So the first thing I'm going to note is I've got a relationship between AE and AB, and I want to determine M in terms of N. So I'm hoping that I can eliminate some things. I'm going to tell you the path I'm going to follow, just the overall path, okay? What I'm going to do is I'm going to get to a point where I show two vectors are equal. That's my aim. I.e. it's going to be AE equals KAB. I'm going to show they're equal. Now what that will produce is a something A plus something B will be my AE, and then K times something A plus something B will be my AB, and I'll end up with vectors, two vectors are equal in terms of vector A and vector B. I'll be able to equate my vector A and equate my vector B. That's using that linear dependence rule, which I'll go back and show you when we do it. So that's where I'm heading. I'll end up with two simultaneous equations in terms of K. I'll eliminate the K. I'll be left with M and N only, and then I can work out what M is in terms of N. That's the plan. So let's start by saying, what is AE? AE is this little green line here. How do I determine AE? Well, to get from AE without following this green line, because I don't know anything about it, I'm going to go from A to O, which is just negative vector A, and I'm going to go from O to E, which is great because I worked out O to E in part A. That also makes me happy because I'm using my part A answer, which is pretty common in maths. So I've got that to that. So I'm going to determine my AE, I'll just put here, and AE is equal to AO plus OE, which is equal to negative A plus all that stuff earlier, M minus NMA minus a half NB. Is that right? No, plus a half NB. That's right. And then I'll just factorise that A in, so I get M minus NM minus 1 A plus a half NB. That's the first one, so I'll call this number 1. Try another pen. And I'm also going to say, and AE is equal to KAB. What's AB equal to? I'll go back to my diagram. How do I get vector AB? Well, to get AB, I just go AO and then OB, which is actually just negative A plus B. So this is a bit easier, this one. So I get equals K times negative A plus B, and that gives me negative KA plus KB. And so now I can equate those two. This is vector, this is number 2. Therefore, those two are equal. So I get, therefore, negative KA plus KB is equal to M minus NM minus 1A plus half NB. And so I know that's true. I've got K's, N's and M's, which is a bit of a pain. But my linear dependence, let me just go back up to this. So I'll just scoot up. It is right here. This bit here, if you've got MA plus NB equals PA plus QB, then M must equal P and N must equal Q. It's the only way that can happen. So what I'm saying there, if I just scoot back down, that is definitely true, is that negative K must equal all that stuff, and K must equal this stuff. And so I'm going to write those two things down as two simultaneous equations. Negative K equals M minus NM minus 1, and K equals a half NB, equals a half N. And so therefore I get, this is an easy, substitute K out of the first one using the second one. I get half N equals M minus NM minus 1. And now the question says, if A, E and B are collinear, find M in terms of N. So let's find M in terms of N. So I'm going to add 1 to both sides. Half n plus 1 equals m minus nm. So that means m, 1 minus n there, half n plus 1. And then therefore m is equal to half n plus 1 over 1 minus n. Oh, sorry, that should be negative there. Negative. That should be negative. That should be negative. So that should be negative. And I'm just going to neaten it up by doubling the denominator and the numerator to get rid of that half. And I get 2 minus n over 2 minus 2n. And that's neater and about the best I'm going to get. Any questions? I'll just zoom out a little bit so you can see all of at least that. I've overcooked it, admittedly, because I just wanted to show you every single aspect of my justification. You probably don't have to go that far. But the fact is, that fell into place based on a decent understanding of collinearity and of those linear dependencies, where the coefficients of vector A and the coefficients of vector B must be equivalent, and just getting a decent diagram and following. To get AE, I just recognise that's equal to AO plus OE, etc. And setting up equations from that. But like I said earlier, and I'll put this in words on a video, that's a hard question, probably a little bit beyond what I would give you in an exam, but certainly a good type of question to practice. So I would write it down, then I wouldn't touch it for a week, and then I'd come back and see if I can do it.